In this video, we have the integral of x multiplied by x plus 5 to the 8th, and we're going to evaluate it using U-substitution and integration by parts. And of course, you could also do it the long way and expand it, but you don't want to do that. So I did the U-substitution first. I'm going to let u equal to x plus 5. Then du would equal to the derivative of x plus 5, which is 1. And then it's times the dx. So I want to express this integral then in terms of u. So obviously the x plus 5, that's going to be your u. I don't want the dx, I don't want the x, but notice here, dx will be the same thing as du, so that takes care of this. And then for x, I can solve this first substitution here for x, and this would give me x taking the 5 over will equal to u minus 5. So for the x, I replace it by u minus 5. X plus 5, that's to u, and that's to the 8th power. And then dx and du are the same thing, so this would be du. And then we just go ahead and multiply here. That's the integral. Multiplied through, this will be u to the 9th, u to the 1st, and u to the 8th, u to the 9th, then minus 5 times u to the 8th. Now we have the look of a polynomial here in terms of u, so this would be simple integration, term by term. Add 1 to the 9 here, we get 10. Divide by 10. Add 1 to the 8, we get 9. And divide by 9, and then we have the constant of integration. Let me go over here to have more room. Now all we have to do is just go back to the original variable. So when you have the u, go and put x plus 5. So we got x plus 5 to the 10th, and that's over 10. And then in the next one, we have minus 5. And now again, when I have the u, put x plus 5, so it'll be x plus 5 here. Just taken to the 9th power, and that's over 9. And then we have the constant of integration here, and that's the answer. Now, in some situations, working one from the textbook, the answer might look different. They might combine this, find a common denominator here of 90. And write it as one fraction. But for this video, we're going to leave it like that. And always, again, you can always check. If you're not sure of your answer, you can always check by taking the derivative. That's good derivative practice. So let's see if we could see if this one checks out. Let's do this one. So this will be 10. Derivative of this expression, bring the 10 over. That cancels. Subtract 1 from the exponent. That leaves the width for the 9. And then for this one, multiply through. Again, it's constant here, so just go 9 times over here. But that cancels the 9 in the bottom. So that's going to be minus 5. Subtract 1 from the exponent. And we get x plus 5 to the 8th. We want to get the integrand. So here we have to do a little bit of algebra. So let's factor x plus 5 to the 8th, and that leaves me then, this will leave me 1 factor of x plus 5, and this will leave me just a minus 5. So those cancel out, and you're left with x times x plus 5 to the 8th, because you're taking a derivative. But anyway, you see that we do get the integrand, x and x plus 5 to the 8th. So that's the answer to that one using U-substitution. Now for the second method, integration by parts, general formula is integral of u dv, and that's equal to the product of u, and then we have to find v. You picked up what you want for u, and then you want to pick something for dv and integrate it. You get this, and then it's minus the integral, and then whatever v is, this will be du. And this will be the standard formula. there's some shortcuts you can take, but this one's not too bad. So for this one, then I'm going to let u equal to, again, we have two factors here, this one and this one here. Sometimes you can break it up if you need to, but here it works out okay if I let u equal to x and let dv equal to what's left here, x plus 5. X plus 5 to the 8th. And then we'll have the dx. So we're going to need a du. So du, be derivative here, derivative of x is 1. That'll be du equal to dx. And then this one I want dv, so I want to integrate this one. It'll be the integral respect to v here will be this will be v here. And the integral of x plus 5 to the 8th, because the derivative of x plus 5 is 1, you would let u equal to this, but all it's going to be is x plus 5 to the 9th over 9. Check it out. Take the derivative, 9 comes out of here, it cancels. Subtract 1, that gives you that answer there. And now we can go back to this problem here. Equals 2. So by the formula then, the first part of the answer is going to be the u multiplied by whatever v is. Okay, so there's u is x. This will be x. And v is this right here. So this will be x plus 5 to the 9th over 9. And if you look at the formula, then it has a minus. So I put a minus here. And then it has an integral here. So it's the integral of, says v, whatever v is. So that's this right here. This will be x plus 5 to the 9th over 9. And that's times du here. Notice v, this is v, and then du. But du is dx. So this is going to be dx. So again, this gives me then x plus 5 to the 9th. This is all over 9. And then it's minus here. And again, because you have a constant here, or a 1/9 here, and the derivative of x is 1, again, it's just like integrating u to the 9th. So it'd be adding 1 here, which would give me x plus 5 to the 10th. And then you divide, it's the same thing, multiply by 1/10 here. So 10 times 9 is 90. And then it's plus the constant of integration. And that's your answer for this one. Now this one doesn't look like the other one. We did it by a different method, but it still works. Now you can do what I did in the first one and take the derivative of this here. For the first term here, you're going to have to use the product rule. And then over here, and then simplify, it will give you the integrand. But that's the answer we get for that one. And just so you see it more, these are the answers we got. So using the U-Substitution, this is what we got. Using the integration by parts, this is what we got. Check it out here. Use the product rule in this one because you have the product of x and x plus 5. Here it's just a constant. So the here is just going to be 10 over, gives you a 9, subtract 1, you get x plus 5 to the first. And don't forget to take the derivative of this because you use the change rule. But in this case, it's not going to matter because the derivative of x plus 5 is 1. Because the derivative of 5 is 0, and the derivative of x is 1. But take the derivative of the second one there, and show that you do get the same integrand. That's the solution for this problem, the two methods. Thanks for watching. We'll see you next time.